Welcome everyone. I'm Norman Wildberger. I'm an associate professor at the University of New South Wales in Sydney, Australia. And this video is going to introduce you to a new series that I have planned. Series of videos that will try to explain elementary mathematics to a very general audience, including an audience of people that perhaps have had very little background in mathematics, who have very little appreciation for mathematics, maybe are a little bit frightened of mathematics, or perhaps even resentful of the mathematics they learned back in school. Now, the years K to 6 are quite important, of course, because they lay the foundation for further success in mathematics, which translates to success in a lot of other adjacent fields, be it the sciences, economics, business, law, medicine. A lot of things are dependent on basic facility and understanding of elementary mathematics. So I think it's very important that we have a look at this subject. Of course, there are many people involved in mathematics education who are very interested in this subject, and a lot of work has been done. I'm a little bit outside that loop because I'm a pure mathematician who writes papers and books and so on very abstract things. And if you've watched some of my other YouTube series, you will know I have interest in geometry and other things. But I think it's really important for pure mathematicians to step up to the plate and to address certain ideas in mathematics education at this young age. In particular, I'm particularly focused on the importance of content in mathematics education. I think the most crucial question when you're teaching mathematics is almost always, what are we going to teach? It's not how are we going to teach, it's what are we going to teach. All the other things to me are secondary in the sense that you have to decide what you're going to teach, and you have to know the material that you're going to teach. There is no getting around that the knowledge of the teacher is crucial when it comes to educating people. And I, together with many of my colleagues, my pure mathematician colleagues, and my probably applied mathematicians and statisticians would agree, a lot of us feel that one of the difficulties that modern mathematics education faces throughout the world, and I'm not talking just about Australia here, is the lack of solid understanding of mathematics by primary school teachers. Now, this is not to say that it's their fault, okay? It's a fault of the whole system, the way it's organized, the way teachers are taught, the way teachers are rewarded, etc., etc. But I think it's really important that teachers have a stronger understanding of mathematics, and that mathematics educators think about how are we going to strengthen the understanding of teachers. Another aspect of that, of course, is parents too. If parents are more knowledgeable about mathematics, they can help their children enormously in overcoming difficulties in understanding and computation. So overall, our aims are, first of all, I'm going to try to explain the mathematics in a simple and straightforward way. I'm not going to follow a set curriculum, so don't expect me to go from kindergarten year by year through the curriculum. Rather, I'm going to take the whole thing and I'm going to try to explain the mathematics in my way, in a kind of a novel way perhaps sometimes, but with emphasis on the things that I think are important. So I'm always going to be trying to decide what is important, what's really the crucial thing that people ought to know here. The aim, of course, is to strengthen teachers' and parents' understanding. I've already talked about how important both of those things are when educating young people. And when I say understanding, I'm talking about understanding of the mathematics, of the actual content of the mathematics, and also related content. So not just exactly what's on the curriculum, but the broader context. How does what we're learning here fit in to a bigger picture of mathematics? And I would be really happy to get more people interested and engaged in mathematics and maths education. I suspect there are a lot of people out there who perhaps struggled with mathematics, perhaps disliked the experience, but they somehow feel as if they're missing something. That if circumstances had been a little bit different, perhaps they would have done better at it. Perhaps they would have enjoyed it even. So I'm trying to catch some of these people that might think they don't like mathematics. I want to convince you that it's actually quite interesting and it's actually not that hard. So my aim is to have each lecture in the series roughly 40 to 50 minutes long, something in that ballpark. The first lecture will have a name something like LM Math 1, counting using the grid plane. The second one will be LM Math 2, arithmetic with rectangles, and so on. So they'll all be numbered with this LM Math, which is the short form, the short title for the series. So, to get something from this course, you don't need the following. Okay? You don't need to like maths. It's okay with me if you don't like maths. It's not necessary. You don't need to have understood it previously. You don't need to have done well in courses. You could have dropped out of math at a very early age. That's okay. I'm going to explain it to you in a way that you can understand. You don't even need to be interested in maths. I'm going to try to interest you in maths. I'm going to try to get you to look at the subject in a new way that makes you think, hey, this is pretty cool. This is not a bad subject at all. Maybe I'd like to know a little bit more about it. And we certainly do not need a calculator or a computer. Okay, so high technology will be put aside. Well, to get something out of this course, I think you will need to concentrate on each video. So I'm rather concise about what I say in these videos, and even though this is going to be an elementary series, I will still be relatively concise. There's not going to be a lot of fluff. There's not going to be a lot of anecdotes that go off in tangential directions. Pretty well everything that I say will be important, and I want you to try to understand everything that I'm saying. So that requires concentration. If 40 or 50 minutes is too much to concentrate, that's no problem. Stop the video whenever you're getting tired. Come back to it later. And also don't be afraid of watching a video 2 or 3 times. There's a lot of material in some of these videos. If you haven't done mathematics for a long time, it might take you a while to get onto it, but slowly, carefully will do the trick. I suggest that you go through the series in the right order. So the series is designed to be gone through in a certain order, the order in which I present them, the labels 1, 2, 3, and so on. Very important, it will be necessary for you to try to do the exercises. I'm going to give you exercises to do in almost every lecture. And I really strongly encourage you to try to do these exercises. And by that I mean not just do them in your head, but to actually have a book, a dedicated book, in which you write down solutions to the exercises. Okay, try to do that in an organized, reasonably neat way. And some of the exercises will be very routine, and some of the exercises you may find more challenging. Some of them perhaps will be very challenging, but perhaps hopefully interesting too. All right, so do the exercises. Mathematics is an active business. You want to try to be engaged as actively as you can. So in that same direction, something else that you need to do is to spend some time thinking about and playing with the ideas. After you've ingested a video, take a walk, think about it, spend some time playing around with examples that illustrate, that go over the material of the lecture. So I'm looking forward to this. I think it's an important project, and I'm kind of excited about it. So I'm looking forward to it, and who knows, you might enjoy it too. I hope so. So with the first video in the series, the next one, we're going to start with counting using the grid plane. Very simple arithmetic in a very simple and structured but interesting geometrical framework. For that, you might like to get a book that has some graph paper in it. That will be an important tool for us. So I hope you'll join me for that. I'm Norman Wildberger. Thanks for listening.